buku siap-siap buku untuk salin Okay, Assalamualaikum and welcome back to week 5. Okay, for today's class, we're going to go through curvilinear still. However, today for this class, we're going to focus on non-rectangular components. Yeah. Okay, so for curvilinear, you must understand there are actually 3 types. Okay. Okay, I want you to understand this. So I'm making a chart like this. So first you've learned about motion of projectile. Okay, that is easy, eh? Okay, motion of projectile, eh? Okay, so motion projectile you learn is for free flight motion, eh? Free flight motion of a projectile. And you remember you had to come up with equation of what? Horizontal motion and also for vertical motion. Okay, those are the things that you did for motion of projectile. Okay, do you understand? Am I okay?
Yes,
Do
madam.
you remember? Boleh, can I continue? Okay, all right.
Boleh, boleh.
And next, there is another curvilinear where it is called normal and tangential. Okay, so this one we are supposed to do it last week, but we wasn't able to do it due to I'm having a house blackout, but we'll do it today. So today we're gonna do on normal and tangential, and there is another one that is on radial, and transverse. Okay, so for curvilinear there are 3 types. Okay, so when you get the question, the first thing that you need to do is you need to decide, okay, this is a topic curvilinear, is still kinematics, okay, still kinematics of particles, but then you have to decide, am I going to use motion of projectile, normal and tangential, or radial and transverse? So normal and tangential is N and T lah. Radial and transverse is theta and R. Okay. So these are the components that you need to decide how are you going to solve your curvilinear questions, okay? But don't worry, we have done a lot of questions on motion of projectile, and you understand it involves, for example, 2 points where you throw one thing and you reach another point, and it involves due to gravity, and it's a free flight. Okay, so normal, today we're gonna just learn a little bit on normal and tangential and radial and transverse, so that when you get questions related, you will understand how to solve it. Is that fine? Can we continue?
Yes, madam.
Okay, all right, don't worry too much. Okay, yeah, you're thinking, oh, there's a lot. Okay, but it's fine. We'll go through normal and tangential, and then we'll do a lot of examples, and then you understand, oh, okay, it's that simple. Okay, so usually for normal and tangential components, normal we use the symbol N lah. Okay, tangential we use the symbol T lah. Okay, so when the path along which a particle travel is known, then it is convenient to describe the motion using the N and T coordinates. Okay, so sometimes when you know the path, okay, and it gives you origin location of the particle, then you can use normal and tangential. So for your information, the normal and tangential and radial and transverse are what you call the non-rectangular components. Okay. Okay, if you remember when we did motion of projectile, it is we are doing the rectangular components. Okay, rectangular components means it means that when you do motion of projectile, you need to resolve the questions in terms of x and y coordinate system. Remember? Okay, in x and y coordinate system. That's why a motion of projectile is what you call rectangular components. Okay, right. But right now, what we're doing is the non-rectangular components. Okay, so today we're gonna understand how to solve questions related to non-rectangular components. Okay, right. Just listen first, understand first the fundamental, the theory, the concept, and then later on when we start doing our examples together, you will be able to understand much better. Is that okay, guys? Hmm?
Okay.
Okay,
Kita
madam.
semua ngantuk ni.
Okay, madam.
Okay. Alright. Okay, don't worry too much.
Monday
Dynamic
blue.
is easy. It's just that you need a lot of practice. Okay. All right. So Azmina Sari, is it okay?
Okay, madam.
Okay. All right. Okay. Now, so let's assume okay now focus. We're doing normal and tangential. So let's consider a particle which moves along a plane. Okay, along a plane that is fixed, curve. So this is a curved plane. Yeah. So when you have a particle, it starts here 0 and it moves along a plane. Okay, let's say the particles here. So what you need to do is um, um, the position of the particle, the distance of position of the particle will be from here to here lah. Dia punya distance lah, S lah. Okay. Now what you need to do is you need to consider a coordinate system from its origin on the curve. Okay, all right. So this is the coordinate system. Okay, that you need to do. So what you need to do is you need to write down the direction of the unit vector. Okay, so the direction of the unit vector. Okay, number one, you need to write down what is n and t. Okay, t is always going to be tangent to the path. So let's say this is our particle. So tangent to the path will be like this. All right, guys, boleh? Okay, and then normal to the path will be perpendicular to it. This is n. So when you get a question, okay, any questions in the future, what you need to do is, let's say you get any questions in the future, you have a particle here, particle here, particle here, and you need to identify the normal and tangential components. So you know that the tangent, so let's say the origin is here, so the particle is moving in that direction. So the tangent will be, this will be the tangent, this will be the tangent, this will be the tangent. And the normal will be concave. Concave to, okay, assume concave will be concave to the curve. Let's assume, let's get yellow, something like, okay. Concave tu dia macam, okay, let's say you need to identify where to put your end condition. Okay, you draw a circle, a concave circle like this. Your end will be there. Am I right? Your end will be that direction. Your end will be that direction. Okay, do you understand? So your first step when you get a question that is related to normal and tangential, what you need to do is you need to identify what? These two things, which is the normal and the tangential
Tangent.
component. Okay. Okay. Once you get that correct, then you can continue. Okay. Because that is important. You need to draw that in your diagram. In your question diagram, because it gives marks. Okay. All right. Okay. So the unit vector is for normal and tangential. what we use is the unit vector is usually what we use is ut for the tangent, and then un for the normal. Okay, all right. So don't forget you need to write utn un. Okay, all right. Now we will this is what you see here is the planar motion lah. Okay, what you see above here is what you call the let me write down the planar motion. Okay. So you understand how to draw the planar motion is good. Okay, next, after you have understand that, you need to understand the velocity. Okay, now. Okay, as I mentioned, if you have a curve like this, the velocity will be always tangent to the path. So this will be the velocity, because it's always going to be what? Tangent to the path, Okay, so this is the velocity, So velocity V is always what? ds over dt, Okay, um that is for apa? Apa? Velocity lah. Okay, next is for acceleration, So maybe you should write it down. Velocity is always tangent to the path. Okay. 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 Now we need to write for the acceleration. Okay. For the acceleration, there will be two types of acceleration. Okay. For acceleration, you have two types of acceleration that you will need to consider. One is the tangential acceleration, and the other one is the normal acceleration. Okay. For the tangential acceleration, okay, for the tangential acceleration, hold on, let me write down. The formula is the normal formula. Okay, for the tangential acceleration, we have AT, we have V, we have S, and we have T. Okay, these are the normal kinematics, right? So for the tangential acceleration, the formula will be dV over dt lah. Or you can also use AT ds equals to V dV. Remember this formula? Remember this formula, guys?
Yes.
Okay, good. All right. Okay. Let me just circle these important formulas. Okay, that is for the tangential acceleration. And then for the for the tangential acceleration, there's also another type of acceleration where you use the constant acceleration. Remember, AT equals to the constant acceleration, which is V equals to V naught plus AT C T. Lagi, remember these ones? Do you remember, guys?
Yes, madam.
Okay, good. Okay, we're still using it, okay? I'm writing AT and then in the bracket, outside the bracket is C. Okay, S equals to S naught. Okay, all right. So in the question, you will need to find what is AT, and then you need to decide you want to use AT using the kinematic equations, or you want to use AT using the constant formula. Okay, and then you have the normal acceleration. Okay, the normal acceleration we use AN, and the formula is different, is V squared over rho. So this is a new formula for you. Okay, all right, and then rho is the radius of the curvature. Is the radius of the curvature, and sometimes the formula rho is not given, so you need to find. So it will be 1 plus dy over dx squared bracket 3/2 over d2y over dx squared. Okay, this one if they don't give, okay? Right now. Okay, now for acceleration is the same, like we need to draw how we're going to draw it. So usually for acceleration, let's say we have a curve like that, and then we have a point P here, the particle. So again, we have to draw the AT, AN. So this will be our AT, okay? This one will be our AN. So our acceleration is this direction, A. Okay, so if they ask you to find the acceleration, there will be another formula that you need to find. So acceleration will be A equals to square root of AT squared plus AN squared. Okay, so this is the formula. All right. Okay, all right. So let me, are you copying, guys? Okay.
Yes.
Okay.
Yes.
Okay, don't feel stressed. Nothing is wrong. Okay, it's easy. So let's say, okay, let's say you need to draw the particle. This will be AT, this will be AN, and how about our acceleration? Like this. Okay, and then let's say, you have another particle here. Okay, so this one will be our AT. Here will be our AN, and our acceleration will be like that. Ah, okay. So what is AT and AN? AT is the change in magnitude of velocity. Change in magnitude of velocity. And what is AN? AN is change in direction of velocity. Change in direction of velocity. Okay, now let me just highlight. So there are a number of important formulas. So here you have this one, velocity, and then you have tangential acceleration, okay, or either these. And then you have the normal acceleration, okay. And in case they don't give you the radius of curvature, this is the formula. Okay, all right. Okay, now, okay. A good example to represent this is a kid on a swing. So let's say you have a swing, you're going to the playground. Okay, this is the swing. Okay, let's draw a swing. Okay, so let's say we have a kid is swinging on a swing. Okay, okay, let's draw the boy or the girl. Okay, so this is the boy or the girl on the swing. So what happened is the direction of the direction of the T will be like that. Am I right? Okay, and then the normal direction will be N like that. Am I right? This is how you draw it. Betul tak? Because the velocity is tangent to the path. This is tangent to the path, kan? Okay, all right. And the normal, how you draw the normal direction, it must be perpendicular to the direction of the tangent lah. Kan, this is 90 degrees lah. Okay, all right. So your AT will be like here, and your AN will be here. Okay, so this is a good example, or example. So a boy on a string, so is moving like that. They move curve like that. They're going up and down, up and down. Let's draw this person smiling. Okay. All right. Okay. Have you finished copying?
Yes.
Dah habis dah copying. Okay. Nick Shahril. Nick
Yeah,
Shahril.
madam.
Are you okay?
I'm okay.
Okay. All right. Okay. So, all right. Okay. So, this is a normal and tangential. Okay. So, if you're okay, we can do one question together. And then later on, we'll go to radial and transverse. Okay? Boleh?
Boleh, madam.
Okay. So, let's try one question together that is referring to apa a normal and tangential so that you can understand better. But now you understand the scenario, how to solve the questions related to normal and tangential. Okay. You need to use these formulas. Okay. So basically, maybe the new formula today is only this one lah. This is new, this is new, and this is new. But the remaining formula are the standard formula that you always use, from the basic kinematic equation. Okay, so just three apa new formulas for today's class. New. I'm writing here new. Okay, but don't worry because everything is open book, kan? Okay, let's try one question together so that you can understand. Okay, please copy. Question. Okay, let's try this question together. A race car C travels around the horizontal circular track. Okay, that has a radius of 300 meters. Okay, meters. Okay. Now, if the car increases its speed at a constant rate of 1.5 meter per second squared, starting from rest, determine the time needed for it to reach an acceleration of 2 meter per second squared. Now, the question is, what is its speed at this instant? Okay. Okay, now, so let me draw. Let's say we have a roundabout. Oops, doesn't look like a roundabout. Roundabout. Oops. Okay, let's say this is a roundabout. Okay. Okay, not a nice circle lah, but it's okay. All right, and then we have. Okay, I don't think it's a nice circle. Okay, make sure you draw a nice circle, nice roundabout circle. Let me try again. Okay. Okay. Oh, all right, boleh lah. Okay, let's say we have a car. Okay, the car is on a roundabout. Okay, this is the car. Okay, no, I want to make the car red color. Okay, let's say this is the car. Okay, so we have a car. Okay, the car is C. Okay, all right. And the radius from here to the center is 300 meter. Okay, the R, the radius. Okay, and this car. Okay, This is don't want to rub. Okay, never mind. C. Okay. The car is going that direction. Okay, now a race car C travels around a horizontal circular track. Okay, now when you see circular track, you know that this is what? Curvilinear lah. Topic curvilinear lah. Okay, and it has a radius of 300 mm. Okay, the radius is 300 mm. Okay, now if the car increases its speed at a constant rate of 1.5 meter per second squared, starting from rest, determine the time. So the first question they asked you to determine is the time, and also needed for it to reach an acceleration of 2 meter per second, and what is the speed at that instant. So we need to find, for this question, we need to find the time, we need to find the velocity. Okay, how are we going to do that? Okay, so when you see this question, because why isn't this question motion of projectile? Who can answer me? Uh, Sharul Azlan? Sharul Azlan, are you here? Shahrul Azlan bin Shahidan. Sharul Azlan? Kenapa tak jawab Sharul Azlan? Are you present in my class, or you just are online but you're not there, you're not sitting in front of your PC? Okay, I'll take note. Sharul Azlan, make sure you contact me back. Siti Nur Akila?
Yeah, madam.
Okay, I'm asking you a question. Why isn't this why isn't this question motion of projectile? Do you remember? When you get a question, you have to decide, are you going to use which coordinate system you need to use? So there are 3 types of coordinate system to use. Okay, what are the 3 types? Either the motion of projectile, normal and tangential, or radial and transverse. Okay, radial and transverse we haven't learned yet, so it's only either motion of projectile and normal and tangential. Why isn't this question a motion of projectile question? Siti?
Because it's move in a circle.
Okay, move in circle. And the other thing is, for motion projectile, it must be free flight motion, whereby it is like thrown up in the air and due to gravity. For this question, there's no gravity involved, right? Understand, Siti?
Yes, yes.
Okay, so for this question, you need to choose normal and tangential. Normal is N, tangential is T lah. Okay, so for this question, first you need to draw the T and N coordinates. So can you please draw? So you know T is tangent to the path. Okay, the velocity is tangent to the path. So we can say this, oops, how to draw T? We can say, okay, oh lah, tak cantik betul. Okay, we can say T is something like this, and N is like that. Okay. All right, guys, betul tak I'm drawing it? The tangent and the normal? Okay. All right. And then we can draw the AT. So this will be AT. This will be AN. And our acceleration will be here. Okay. All right. Understand? So these are the components that you need to draw. Understand tak,
Madam,
guys?
nak tanya boleh? Nak tanya boleh?
What is important is you need to be able to draw the normal and the tangential coordinate. Okay. You need to be able to draw the direction. Okay. Boleh tak?
Madam.
Zuhair Zakwan, are you here? Zuhair Zakwan. Okay, Zuhair Zakwan pun tak ada. Siti Nurul Huda Wan Faizan. Siti Nurul Huda Wan Faizan. Siti Nurul Huda Wan Faizan, Zuhair Zakwan. Okay, and Sharul Azlan. Okay, all right. I can see because you're not online. That's why I know.
Medium.
Okay, never mind. Okay, going back to Sufi. Sufi, are you here, Sufi?
Yes.
Okay, nobody is answering.
Yes.
Okay, what is happening? You want me to
Madam,
call the
madam.
attendance for this class?
Oh, madam. Madam dengar tak saya tanya? Madam dengar tak?
Oh, hello.
Hello?
Hello, madam.
You all jawab Saya punya apa mikrofon mute. Saya punya apa? Speaker saya lowkan volume. Okay, apa? Saya salah lah. Okay.
Madam, nak tanya yang AN tu boleh ada lagi?
Boleh?
Yang AN tu kenapa tak ke atas, madam? Maksudnya keluar.
Okay, kenapa tak keluar? Okay, very simple. Okay, first of all, I apologize. I didn't realize that my headphone kan dia ada volume kuat atau slow atau loud tu kan. Rupanya saya tertekan off. That's why I couldn't hear any one of your voice. Okay, saya salah Okay. Cara dia very simple if you want to know the direction of the AN, I have told you before, this is our curve. Okay, so let's say this is our car. Kan? Dia punya end must be concave. Let's say this is, so you have to draw the circle. So the end will be this direction. This will be T. Let's say the car is here pula. You need to draw the circle like that. The concave. Ni namanya macam concave. Ni. Yang ni. Bulat ni. So the end will be there.
Inside.
Inside, yes. Okay,
Means point towards the center.
center, yes, or point to the center of the circle. Do you understand? Boleh? Sama.
Boleh, madam.
Okay, all right. Towards the center of the circle. Okay, good. All right. So that is a good question so that you don't make mistake in the direction of your end lah. Okay, all right. So but right now our car is moving in a circle direction lah. So kalau the car is here, N will always be like that, T will be like that, and then if the car is moving here, this is the T that direction, and like that. Macam tu lah. Boleh? Is that okay?
Okay,
Okay,
madam.
madam.
Okay, all right. No, so where are we? Okay, number one, we need to find the T. Okay, so we need to find T and we need to find N. Okay, but however, before that, let's write down the information we have. Okay, the information we have is number one, what do we have? We have the radius of 300 meters. So radius of 300 meter is same symbol as rho. So we have our rho lah. 300 meters. Okay, what else we have? We have uh, the car increases its speed at a constant rate of 1.5 meter per second squared. Okay, when they say the car increases its speed at a constant rate of 1.5 meter per second squared, do you think that is AT or AN?
AT.
Yes, AT, because what is AT? AT is the derivative of apa time and velocity lah. Okay, okay. So AT is 1.5 meter per second squared. Okay, next, what other information do you have? That's all right. Okay, you do also have the acceleration. Acceleration is already given. Acceleration is equal to 2 meter per second square. Okay, somebody punya mic is making sound Siapa punya? Siapa punya is making that sound? Okay. All right. So you have these three information in front of you. But now the question is to find the time and velocity. Okay, now to find the time. Okay, how are you going to find the time? Okay. Now let's look back at the formula above here. Okay. Which formula has time? Hmm. Which formula you want to use?
Constant acceleration.
Constant acceleration. Okay. Now, if you look at the constant acceleration, the time, let's use the first formula. Okay. So it will be what? V equals to V naught plus AT C E T. Okay. Now, do we have V? We don't have V yet. We are trying to find. Do we have V naught? Do we have V naught, guys?
Yes.
What is V naught?
0
How do you know it's zero?
starting from rest.
Yes. The word starting from rest means that our V naught is zero, eh? Okay. Plus ATC. Okay, our ATC is 1.5 and then T. So our velocity is 1.5 T. So it means we still cannot find the time or the velocity. So maybe we need to find we need to find the velocity. Okay, now how are we going to find the velocity? If you notice, we have acceleration, we have AT, and which formula has velocity in it that we can use? Okay, if you notice, we have AT, we have A. All right, but we do not have AN. And formula AN is what? V squared over rho. Okay, and do we have rho?
Yes.
We have rho. So maybe we can find our velocity using which formula? A. What is the formula for A? A is what? Square root of
80
AT
squared
squared
plus
plus
n.
AN squared. That's correct. Okay, good. So our acceleration is 2. AT is already 1.5 meter per second squared. So don't forget to square plus AN. What is our AN? Okay, let's write AN first. AN is sorry. AN is V squared over rho. Okay, so V squared is, do we have V squared? Do you have V? Guys, do you have V?
Yes.
What is it?
1.5
Okay, so 1.5 T squared over rho will be 300. So this one, what will happen is, what is 1.5 divided by 300? What is 1.5 divided by 300? Can you calculate for me?
1 over 200.
Huh? 1.5 over 300. You jangan lupa ada kuasa 2 ni. There's squared here. You should get 0.0075 T squared meter per second squared. Okay. So this is our AN. Okay, 0.0075 T squared. Okay, jangan lupa squared. So now, from this formula, what can you do? You can find T, right?
Yes.
Okay, can you please find me T? Find me T. And when you get the T, what you need to do, you just put it in here, then you can find V. Okay, so please calculate for me. Find me T. Okay, what is the answer?
13.28.
13.28. Okay, betul. So it's 13.28 seconds. And when you put into the velocity, what you get? Meaning 13.28 times 1.5.
19.92.
Okay, that is correct. Okay, so what you need to remember is the velocity will be always tangent to the path, and then the acceleration will always be directed within the curvature of the path. As long as you know those two things, and then you know all these related formulas at the top here, you can solve the problem. Okay, I'm going to give you one more exercise for you to do. I will give you the answer, but you will need to do it, okay? All right. Okay, that's correct. That's the right answer. Okay. All right. So those who are still calculating, make sure you use your calculator until you get the right answer. Okay, because sometimes because there's square root, there's square, you might miss a few things. Okay. All right. Can I give you another question? So for tomorrow, we will study on radial and transverse. Okay. All right. All right. So just one more question, just to see whether you can do it or not. Okay. A motorist is traveling on a curved section of highway. Oops. Of radius 750 meter at the speed of 90 kilometer per hour. The motorist suddenly applies the brakes, okay, causing the automobile to slow down at a constant rate, okay, knowing after 8 seconds the speed has been reduced to 72 kilometer per hour. Determine the acceleration of the automobile immediately after the brakes have been applied. Okay, so this is the question. It's very similar, slightly different. Okay, so here, okay, let's have a picture of a car. Okay, let's now draw the car purple in color. Okay, so this is the car and the radius is 750 meters. Okay, and it's going in this direction at 90 kilometer per hour. Okay, now, so this question, okay, I give you the answer. Okay, the answer is, okay, the answer, okay, what is the question? Okay, let me read the question. A motorist is traveling on a curved section of the highway. So now you know, okay, this is a curved section. Okay, if of course it's curvilinear. Okay, and then they have a radius. Okay, 750 meter at the speed of 90 kilometer per hour. Okay, so this one should be rho lah. Okay, now the speed is 90 kilometer per hour. Okay, when the speed is 90 kilometer per hour, when you get a question in 90 kilometer per hour, you need to change the unit. 90 kilometer per hour, you need to change to what? Meter per second. How do you change 90 kilometer per hour to meter per second? How do you do that?
Time power,
Hmm.
time with 10 power of 3, then divide by 60.
Divide by 3,600 second. Macam mana you convert tu? Okay. So to convert this in any question dynamics, in any question dynamics, it must always use unit meter per second. So any question that you get in 90 kilometer per hour, you have to convert to meter per second. So to convert it is 90 kilometer per hour multiplied by 1,000 meter per 1 kilometer is 1,000 meter, and then 1 hour is how many seconds? 3,600 seconds. So from there, what you can do is you can cut this one, this one, and then you will be left with meter per second. So what is the answer?
25. 25 meter per second.
Okay. 25 meter per second. Okay, good. Okay, so that is the speed, 90 kilometer per hour. The motorist suddenly applies a brake, causing the automobile to slow down at a constant rate. Okay, knowing after 8 seconds. So after 8 seconds lah, and then the speed has been reduced to 72 kilometer per hour. So 72 kilometer per hour ni pun you have to change unit. Okay. Now the question is, determine the acceleration of the automobile immediately after the brakes are applied. So it wants the answer for acceleration. So the answer for acceleration is 1.041 meter per second squared. Okay. So this is the answer. So I want you to try to do it, and then if you want me to check, you can just show me your solution lah. Okay, same as the question of the test that I give you last week. If you want me to check, show me your solution lah, and I can guide you lah. Okay, so now try to solve this question. So for this question, of course, you know that this question you have to use normal and tangential component to solve it. So in your diagram beside here, you need to draw the normal and then the tangential component. And then again, you need to use what information here, given here, this formula to solve the question. Okay. All right. You have to decide which formula you want to use. How are you going to solve it? So obviously, for this question, very simple lah. They ask you to calculate A. So when they ask you to calculate A, of course, you know that you need to find AT dengan AN lah. So what is AT and what is AN? You have to find out. How do you find AT? How do you find AN? Okay. All right. So you must find. But now there is other two speed. Okay, first it was 90 kilometer per hour. Then after that, they reduced the speed to 72 kilometer per hour. Okay, ada trick sikit kat situ, but it's very simple and straightforward. Okay, can you please try this question and then come back to me with the answer? If you get the answer correct, it means your solution must be correct lah. But if you don't get the answer and you don't know what to do and you're stuck, you can ask me. Okay, don't be afraid to ask. I always reply your messages. Okay. Okay. Anything else? Because it's already 11 o'clock. I have another class.
Okay, madam.
Okay, so please don't delay your that that thing that I gave you last week, on motion of projectile question. Okay, if you can do that, then you'll be very good lah. Shows that you are very good. Okay, all right. So we start our class today. Okay, Zuhai, I saw you just entering our class. Why were you late? Okay, so let me stop recording first, eh? Okay, all right, thank you. I will see you tomorrow, eh? Okay. Okay, Zuhair, why are you late? You ada exam? Tak dengar lah Zuhair apa dia?
Saya terlelap.
Terlelap. So, macam mana boleh tiba-tiba you terbangun?
Alam.
Ada alarm. Tak ada kawan yang telefon? Ha? Ada. Kawan telefon angkat tak?
Tak dengar kot.
Tak dengar. Okay, so you are lucky today. I have recorded this class session. Nanti I will give you the recorded video and then Zuhair, can you please watch it? After you have watched it, then only you fill in the attendance. Is that okay? Okay, Zuhair?
Okay.
Alright, okay. Nanti I will give you the recorded video later lah because there are some important things we have discussed here on normal and tangential, and then you need to copy all these notes, okay? To understand better, yeah? Okay, good. Alright, class. So we stop now for today. So I hope to see you tomorrow. Hopefully you tomorrow when I see you, you segar, bugar, okay? Please jangan ngantuk-ngantuk, okay? Alright. Please look forward to come to class. Okay. Alright. Any other question before we stop today?
No, madam.
Okay, all right. Okay, thank you. I have to stop now and end the class because I have another class there. Okay.
Thank you, madam.
Okay. All right. Okay.
Thank you,
Bye,
madam.
class.
madam.
Okay.
Thank you, madam.